Okay, so let's take a look on this worksheet to see some of the mean value theorem problems. So we're going to start with just Rolle's theorem, and we're going to try and see if it can be used. Okay, so the first thing with Rolle's theorem is I would need to see if f of -1 equals f of 3. All right, so if you put -1 in, you get 1 plus 2 minus 3, you get 0 on top, and you would get 1 on the bottom, so you do get 0 for that, and you will also get 0 if you plug 3 in, so that works. All right, is f continuous on -1, 3? Well, here we have a rational function, so the only issue would be if there's a place where the denominator is 0. Now the denominator is 0 at -2, but look at our interval. Our interval is -1 to 3, so it's not on that interval, so we are continuous there. And again, is f differentiable on -1, 3? Well, it's actually going to be differentiable wherever it's defined, because it's a rational function. And so what we do know is it is, but let's say you had some doubts. Let's just take a look. Let's calculate the derivative. We're going to need it anyway. So let's take, all right, so quotient rule. We're going to be doing 2x minus 2, derivative of the top, times x plus 2 on the bottom, minus the top, x squared minus 2x minus 3, times derivative of the bottom, which is 1, all over x plus 2 squared. Okay, so I'm going to skip a few steps here, but if you multiply all that out, you should get x squared plus 4x minus 1 on top, and you should get still x plus 2 squared in the denominator. Okay, so what we do see is indeed the only place that the derivative has an issue is -2, which is also not on this interval, so we're okay. So Rolle's theorem applies. So now, because this is Rolle's theorem, we know that the guaranteed value of the derivative is 0. And so we're just going to take this derivative we just calculated, okay, now that's only going to be 0 if that numerator is 0. All right, now you're going to have to go and use the quadratic formula on this. Now if you do that, you're going to see that x would come out to be -2 plus or minus the square root of 5. So use quadratic formula. I'm just going to skip some of those steps. Now it looks like we have 2 points according to the theorem, but be careful. The interval is -1 to 3. So the square root of 5 is a little bigger than 2, obviously, because bigger than the square root of 4. So if I took -2 plus the square root of 5, I'm going to get something, between 0 and 1. That's good. So the x value of -2 plus the square root of 5 makes sense. But -2 minus the square root of 5 would be -2 minus something about 2, so we'd be past -4. That is not actually on our interval. So the c value referred to here was the -2 plus the square root of 5. Okay, so now let's go to a mean value theorem example. All right, here we just have to check that f is continuous on the closed and differentiable on the open. But again, since this is a nice polynomial, that's easy. So MVT applies. Okay, so the next thing I'd want to know is, what is this guaranteed value of the derivative? Well, again, that's just going to be f of b minus f of a over b minus a, which is going to be f of 1 minus f of negative 1 over 1 minus negative 1. And this is going to come out to be, so if I do f of 1, if you plug f1 into this polynomial, you should get minus 2. And if you plug negative 1 into this, you should get 0. So you're going to get negative 2 over 2. So you're going to get 1. So there's my guaranteed value of the derivative. So now I want to ask, what is C? Well, I'm going to need the derivative. That should be pretty easy here. 3x squared minus 2x minus 2. And I'm just going to set that equal to this 1 that I found out from the guarantee. So if I do 3x squared minus 2x, and then I subtract over, I get minus 3 equal to 0. You could use quadratic formula or factor this. And this is going to be, whoops, I'm sorry, back up. This should have been negative 1 over there as the derivative, and this is negative 1. And so if I take minus 2 and add 1, then I'll get minus 1 there. Sorry about that. So I have 1 and 1 there, and I need a plus or minus. So this is going to be plus there and minus there. So x of negative 1/3 and x of 1. All right, so those are the two places where the derivative does end up being this negative 1 value. Go back to my interval. Now, this is a subtle point here, but officially, according to the mean value theorem, we're going to find C values inside the interval, so on the open interval, not at the endpoints. So technically, and I'm not really concerned about the details of that, so technically the x equals 1 point is not really referred to by the theorem. So this C of negative 1/3, which is on the interval, is what is guaranteed. All right, so let's take a look at this last one here, x to the 2/3. Okay, is f continuous on 0, 1? Well, again, this is as a power function here that's going to be continuous wherever it's defined, and it is defined there. Is it differentiable on 0, 1, open? Well, if you have any questions, let's take the derivative. 2/3 x to the minus 1/3, which would be 2 over 3x to the 1/3. Okay, so now obviously there is an issue at x of 0, but 0 is not on the open interval 0, 1, so we're okay. Mean value theorem applies. Okay, so what is f prime of c? What's the guaranteed value? I can just do f of b minus f of a over b minus a, or in other words, f of 1 minus f of 0 over 1 minus 0. f of 1 is just going to be 1 if I go back to my original function, and f of 0 is 0 over 1, so I do get 1 as my guaranteed value. What is C? Well, now I take this derivative that we found before, 2 over 3x to the 1/3. I'm going to set it equal to the 1 that I just found. Okay, so that's going to tell me that if I start to simplify this, I would get that x to the 1/3 is 2 over 3. Cubing both sides would give me x is 8 over 27. And in fact, 8 over 27 is between 0 and 1. So there is my guaranteed value. There we go.